Quideo 2, basic problem, linear models and less square regression line equations. So for this problem, we're looking at times and pulse rates for swimming. And for letter A, it's asking us to verify that the linear model appropriately models the data. So what we're going to do for this is we're going to put the times into list 1 and the pulse rates into list 2. And so I've gone ahead and done that in the calculator and then did stat calc linear regression, and I got the equation y equals 479.9341 minus 9.6949x. And to see if this is a good fit for the data, we're going to look at the r squared value, and that's going to be 0.5565. So yes, the linear model is a fit for the data, it's just not a strong fit. But another thing we can look at is the residual plot. So I've gone ahead into my calculator and I've used the list 1 and list 2 to make my residual plot. And this is a really good residual plot because it's got a pretty reflexive property. So the points at the top are pretty equally matching the points at the bottom. So yes, we can say that the linear model does appropriately match the data. So the next problem, letter B, is asking us to use the time to find the pulse rate. And so I used the equation y equals a plus bx because that's the linear regression equation, and I plugged in y equals 479.9341 minus 9.6949, and I plugged in 34.3, which is the time, in for x. And I got y equals 147.39903 for the pulse rate. Well, in the problem, it tells us his actual pulse rate was 152. So the answer was about 4.6 away from the actual pulse rate, which is of 152. So we can say that our prediction was fairly accurate. So for letter C, we're given just the pulse rate, and we're going to predict the swimming time. So the Lester's regression line equation would be 152 is equal to 479.9341 minus 9.6949x, which is the time. And so you're going to subtract 479.9341 from the 152, which gets you negative 327.9341, and you're going to divide that by the negative 9.6949, and you're going to get the time is equal to 33.8254. Well, the time that we were given in the problem above was 34.3, and the time that we predicted in letter C is 33.8254. So the number was 0.4746 off from the actual time of 34.3. So this is also a fairly accurate model. And for letter D, we're trying to explain why there are two different regression lines. And there's two different regression lines because one is the predicted and one is the actual. So for one of the equations, we're given the actual time, and one of them we're given the predicted. So you're just getting two different lines to see which one is more accurate, and you can compare them so you can see how accurate your model fits the data.